Welcome to 7E. We're on page 106. Our last two sections, maybe it was just the last section, we added and subtracted polynomials, so it would stand to reason that we would move on to multiplying polynomials. And this is going to involve distribution, which you guys are real familiar with distribution, but it is good to see this visual here that can represent graphically, pictorially, actually, multiplying a monomial with a binomial. So 3 is your monomial, one term, and your binomial represents the length of this big rectangle, and that is x plus 2. So if you look at the area of these individual rectangles broken up by themselves, remember area is length times width. So if we're just looking at this one that I have highlighted in green, it would be area is equal to, and if we think of the length as x and the width is 3, and we write our coefficient first, our area of just this green guy rectangle is 3x. And then if we look at the smaller one, area is length times width, and this is 2, and this side is 3. So his area would be 2 times 3, which is 6. And then if we wanted to say, okay, I want an expression for the entire area, the area of this entire rectangle, you might say, all right, the area is the 3x of the one rectangle plus the 6 of the second triangle. And this is an expression for the entire area. All of this is gotten from the picture. Well, if we don't want to use a picture and we want to just write it using the area formula, length times width, we can say the length is x plus 2 with parentheses, because this is the length is one expression itself, and it's got to be connected to each other. This x and this 2 go together. They add together to make the length, times the width of the big rectangle, which is 3. When we do distribution, I'm going to move my 3 in front because the commutative property says I can. I'm going to distribute the 3 to each term on the inside of the grouping symbol, and I get 3x plus 6. Same exact answer. So I did it pictorially, and then I did it using the formula without a picture. So we're not going to draw a picture for these examples down here, but you could if you wanted to. So let's go ahead and distribute. You're going to notice that we're going to use our exponent rules when we're multiplying y to the first times y to the first. For example, we are going to get y to the second. We're adding our exponents. And then we're also distributing this 3y to this negative 8. So that's going to give us negative 24y. And we ask ourselves, can we combine like terms? Well, I have a y to the second power here and a y to the first power. These are not like terms. I cannot add or subtract them together. This is my simplified answer. Let's move on. Be sure to watch your signs when you're doing the distribution. A negative 5x times x is a negative 5x squared. And a negative 5x times a negative 3 becomes a positive 15x to the first power. Once again, we can't combine them. So we are simplified after that first step. Let's go down and look at the next one. Again, distribution. 2 times 3 is 6. X to the second times x to the first is x cubed minus 14x to the sixth. No like terms. X cubed, x to the sixth are not like terms. So we are ready to move on to the next one. Distribute. Let's see, what do I have? Okay, I've got an a squared times an a squared. So I'm going to have negative 2a to the fourth b. Don't forget the b. He's part of the distribution. Plus, because we've got a negative times a negative, 4a squared b to the third, because that's a ghostly 1 right there. It's real easy to leave off a sign, leave off a variable, get an exponent wrong. These are not hard, but there's a lot of places to make mistakes. So keep an eye out as you're doing it. Let's go down and do a couple that are a little bit more complicated. We've got addition and we've got multiplication. So PEMDAS is going to tell us we're going to distribute. We're going to do that multiplication before we do the addition. So that's x squared minus x plus 5x minus 5. We're looking for like terms. I do see some like terms. I've got an x to the first power here and here. So I can combine those. A minus 1 plus 5 is a plus 4 of those x's, and the constant minus 5 is on the back end. Let's finish up these couple, and then we'll be done with this video. M squared times m to the first is m cubed plus 3m squared minus 4m minus 12. And I don't think I can do anything else. My exponents are different on every single one of these first three terms, and then the back end is a constant. They're written in descending order, so it's actually in standard form as well. C, a times a is a squared plus 7a minus 1 times a is minus a. Minus 1 times 7 is a minus 7. Again, this is one where these middle terms are like terms, a to the first power. So I can come in and I can say my simplified answer, my final answer, is a squared plus 6a minus 7. So hopefully you found this pretty easy and you won't have any trouble with your practice that you need to do on your own. See you in class.